Waiting again, all these things. Uh, Today we'll be talking about the isostasy. Okay, when we say isostasy, the term is derived from a Greek. Okay, it's a Greek term composed of two words. First is the iso. Iso means equal, and the other is the stasis. Stasis means stand still. Fine. We all observe different land features on the surface of the earth. There are mountains, there are plateaus, plains, and all. Okay, when we talk about the ocean crust, there are different features, land features on the ocean floor as well. Okay, there are plateaus, there are ridges, there are trenches, and everything. When we are observing different features on the surface of the earth, what we find that they are in a sort of mechanical equilibrium. Okay, if you are observing Himalayas, they are present over there since long. Okay, since many years they are over there. So what we feel is that they are in a sort of stable equilibrium stage. Okay, they are in a sort of not exactly in the equilibrium stage, but they are in a sort of equilibrium state. That equilibrium state is referred to as the isostasy. Okay, that equilibrium state, the different landforms present on the surface of the earth, okay, in have some mechanical equilibrium, and that equilibrium is referred to as the isostasy. But we all know, we have just recently studied the plate tectonic theory. We have seen that there are some disturbing forces. Okay, there are different types of endogenetic forces occurring from the interior of the earth, like earthquakes, volcanoes. Then there are different exogenetic forces acting on these land surfaces. If we are talking about the mountains we know, because of the flow of the river, they are getting eroded. Okay, so there are some disturbing forces, endogenetic and exogenetic. So because of these forces, these landforms, they do not achieve that equilibrium stage. Okay, because the mass on those landforms, it is either degrading, it is decreasing, or either it is increasing because of the depositional features. So if we talk about the isostatic equilibrium, it is not observed in an exact manner as it should be. Okay, so basically when we are talking about the definition of isostasy, when we are talking about the definition of isostasy, it is the mechanical equilibrium achieved by different landforms in the absence of any disturbing forces. I'll give the definition. Okay, so isostasy, when we talk about, it is the mechanical equilibrium achieved by different objects on the surface of the earth in the absence of any disturbing forces. Fine, so you can just write the definition of isostasy. Isostasy is the condition of isostasy is the condition of rest and peace is the condition of rest and peace in which the lithosphere and the asthenosphere tend to be. Isostasy is the condition of rest and peace in which the lithosphere and the asthenosphere tend to be in the absence of any disturbing forces. Fine? So, isostasy will be achieved only when there are no disturbing forces. We have already seen the Boger anomaly. If you could remember, we talked about the different land features, the different parts of the crust. We talked about the continental shields. The continental shields are near to equilibrium. We talked about Boger anomaly, that is deviation from the equilibrium. So if 0 is the equilibrium state, if 0 if 0 is the equilibrium state, we can find that the continental shield, they have a value of somewhere near around minus 10 to minus 30. So it is just near to equilibrium. But there are tectonic forces acting on the continental crust. There are exogenetic forces acting on the continental crust. As a result, it does not achieve that exact equilibrium 0 stage. Then we also saw about the mid-continental. Okay, we also saw the mid-continental. They are also in a sort of little bit of stable state. Then as you are moving towards the young fold and the island arc, they are highly unstable part of the surface of the earth. Okay, so they are not in an isostatic equilibrium state. In fact, no place on the surface of the earth is in isostatic equilibrium state. Is that clear? Okay, so this is about the concept of isostasy. So basically, I'll just revise it once again. It is a Greek term, isostasy, derived from two words. Iso means equal and stasis means standstill. Okay, it is a very ideal condition in which the lithosphere and the asthenosphere are in a equilibrium state, are in a mechanical equilibrium state in the absence of any disturbing forces. Fine? In the absence of any disturbing forces. So basically, we all know, we have seen that the lithospheric plates, they are floating over the asthenosphere. It is similar to that of an Archimedean principle. Okay, if you people are aware about the Archimedean floating principle, in that what he has said that certain objects tend to float. For example, an object tend to float over a liquid. Suppose we have already seen an example of a boat. Okay, what Archimedes said that an object floats over a liquid medium. When it is floating over a liquid medium, it sinks to a certain depth. Okay, it sinks to a certain depth to achieve an equilibrium stage where it will remain in a floating state for a long period of time. Okay, similarly, our lithospheric plates are floating over the asthenosphere. Fine? Any doubts, any queries? So that is about the concept of isostatic equilibrium. There are different land features on the surface of the earth. Let's say there's a mountain, there's a mountain, a plateau, plain, and the oceanic crust. Sorry, I have very less space over here. Suppose this below portion is the asthenosphere or the mantle. These are the mountain ranges, a plateau, the plain. Here's the asthenosphere or the mantle over which they are floating. So basically, what this principle of isostasy is that the different land features on the surface of the earth have an almost exact similar length of features extending deep inside the asthenosphere. Okay, there will be some sort of axis. Okay, you can call it as the lithospheric line below which the asthenosphere starts. These are all imaginary things. Just imagine that there's a mountain and there is an extending route inside the asthenosphere over which the different lithospheric land features, the different landforms are present. Okay, if you're talking about the mountains, the higher the length of any landform on on the surface of the earth, similar depth will be there inside the present inside the surface of the earth. Fine, extending somewhat like this feature will be there. So if you see that the volume occupied by the mountain, similar volume of magma present in the asthenosphere is being displaced by its roots. ठीक है, जितना वॉल्यूम ऊपर है उतना ही वॉल्यूम नीचे जा रहा है, एंड वॉट एवर मैग्मा इज प्रेजेंट below it is being displaced. Okay, and thus it is achieving a sort of isostatic equilibrium. Fine, if you want to draw a better diagram, you can draw this one. Okay, then at a certain depth we have seen that the extent of the crust it ends, and an asthenosphere starts. Okay, the length of the crust we have seen it extends from 0 to 70 kilometers. Then there is the upper part of the mantle, which together combined called as the lithosphere, and below that we have a steady layer of asthenosphere. That layer can be called as the level of compensation, below which any land feature extending will tend to melt. Fine, below that any land feature extending will tend to melt. So you can draw this diagram just for your understanding. For every external expression, there is a similar internal expression inside the interior of the earth. So this is basically an ideal condition of isostatic equilibrium. An ideal condition of isostatic equilibrium. Any doubts, any queries in here? Fine. Shall we move ahead? Okay. So I hope you are able to get this concept. If you are talking about construction of a building, we tend to first create its foundation. Fine. So that the building remains in a stable state for a long period of time. Similar is the concept of isostasy. For any land features to remain in a stable state, okay, there will be some roots present inside the surface of the earth. Okay, fine. Then if we talk about the second thing is the historical developments. Initially, in the up till start of the 19th century, it was considered that earth inside is a complete hollow sphere. Okay, so whenever now from here onward when you are studying different theories of isostasy, till that time there were no plate tectonics, there were no continental drift and all. Okay, so all the geophysicists, they were just making some imaginary theories that this might be the conditions. Initially it was thought that earth is simply an hollow sphere and different land features are simply present on the surface of the earth. Okay, then in 1735, Boger, along with his assistant, he was conducting an experiment near Mount Chimborazo, okay, along the equator of the earth. सर्च करना कहाँ पर है, ठीक है, along Mount Chimborazo near the equator of the earth. His basic aim was to find the arc length. His basic aim, these are the different latitudes, the imaginary lines on the surface of the earth. So his basic aim was to find the arc length, the distance between two latitudes. Okay, he he went there, he went near the equator to find the length, the arc length between the two latitudes. He was using an instrument, he was using an instrument as such, okay, a blob instrument. When this instrument is placed on a plane surface of the earth, it achieves a sort of gravitational equilibrium with respect to other stars present in the space, in the universe. For example, like this. Okay, so the plumb blob that was there in the previous diagram, it is in a complete vertical position. It shows zero deflection. Okay, since he was conducting this experiment near Mount Chimborazo, at that point, what happened is there was certain deflection observed in the plumb, that blob. Okay, there was a deflection observed. So what he concluded that, later on he concluded, okay, this deflection was basically because of the mountain. It was not him actually. There were other geophysicists who concluded that it was basically because of the mountain that this deflection was observed. Now, why this deflection was observed is because there was some gravitational effect created by this mountain which was making the blob deflect. So, what he later on concluded that the earth is not an hollow. The earth is not a hollow sphere. There has to be some changes. He was aware of the volume, some hypothetical numbers he had about the volume of the mountain, its mass, and its density. Okay, but since there was some deflection, he thought that these volume and density, they might not be exact. There might be some mass of this mountain extending inside the earth as well. Okay, there might be some mass extending inside the earth as well, due to which there were changes in the gravitational field observed on that particular instrument. Okay, just understand this concept now, how actually it is happening and all. You need not go into much detail about that. Just remember that there was deflection in the plumb blob instrument. Okay, as a result, he concluded that it was basically because of the gravitational effect, changes in the gravitational effect because of the mountain. Hmm? Fine, you can just write few lines. This is some information might be given in your notes, but you can write it. Boger, in his expedition to Andes in 1735, found that the peak of Chimborazo was not attracting the plumb lines in the manner as expected from it. He concluded that the gravitational attraction of the Andes was much smaller than expected. A pendulum, you can, if possible, take a picture of this for your just understanding. If you, or you can download it from Google. A pendulum hangs straight downwards in symmetrical gravitational field. There were n number of mathematical calculations involved in this, okay, in calculating the gravitational force and the gravitational attraction and everything. So from those mathematical analysis, later on it was derived that it was actually because of the mountain. Initially, while he was conducting the experiment, he thought that there was some defect with his instrument. Okay, he was a French, so initially he thought that there is something defect, and probably the conditions at Mount Chimborazo, he was conducting this experiment at a great height, okay, somewhere around 4,000 meter or something. So the conditions were quite harsh over there, and he felt that there is problem with the instrument itself. So he went back again. Then almost by around 20 odd years later on, he concluded that okay, the earth is not hollow. Okay. Hmm? A pendulum hangs straight downwards in a symmetrical gravitational field. The above are the stars. Okay, so with respect to the attraction, the gravitational attraction between two bodies, the pendulum will hang straight. Okay, an equilibrium state is observed on the surface of the earth in the absence of any disturbing forces. Similar such findings were registered. This is there in your notes. Similar such findings were also registered by George Everest, the one who discovered Mount Everest. Okay, then you can just write these lines. Basically, from all the above experiments, it was concluded that the mass and the volume of the mountains would be somewhat different will be somewhat different, and there will be some volume of mountains extending inside the surface of the earth. Because of this extension, there was this Gravitational error observed. You can take a picture of this as well if you want. So basically, now the experiment was conducted. Now, everyone, other scientists as well, okay, there is some extension in the interior of the earth. They now came to know that the earth is not hollow. तो सब उठ गए कि भाई हाँ मैं ढूंढूंगा अर्थ के नीचे क्या है. सब लग गए फिर काम पर. ठीक है. The first one was the airy. Okay. The first one to give a theory about the interior of the earth was the Aries view. He believed that the outer crust was floating over lava or a substratum. He called it lava. Okay, now we call it as magma in the interior of the earth, but तब उसने उसको lava बोला था. ठीक है. He said that the crust is floating over a liquid with a greater density on the lava or substratum. The crust, that is, initially it was called by SiAl, that is silica and aluminium. Okay. He believed that the crust was broken into different columns. For example, when he gave example about the mountains, he said that mountains were somewhat like this, means a columnar. Okay. So he said that the different land features present on the surface of the earth were individual column. Let's say this is the entire crust. It was broken into individual columns. Agar mountain hai to sirf mountain hai. Okay. Then there will be a break. Then there will be plateaus. Okay. Again an individual column. If there are plains, okay, if there are plains, then it will again be an individual column. What he believed that the density of all these individual columns are same. The density of all these individual columns are same, and these columns are floating over a lava or a substratum, a liquid medium. I'll give you better diagrams. पहले कंसेप्ट समझ लो फिर बाद में आपको जो करना है. ठीक है. ठीक है, ये ड्रॉ कर देना, करना ये तो. ठीक है. So he believed that every landforms were broken into individual columns, and these individual columns were extending inside the lava, inside the substratum, based on their weight. Okay. Density is equal to mass upon volume, but he assumed that the density is constant. He said that the density is constant and the different land features are extending inside the lava based on their weight, based on their mass. Okay. So if there was a mountain, it will extend to a great depth. Okay. It will displace the liquid material below it. The displacement for below the mountain will be higher as compared to the other land features. Okay. He conducted this experiment by taking different wooden blocks. Okay. अगर उसने wood ही लिया था तो it is obvious that the entire wooden blocks will be of same density. Okay. If you would have used different material, you would have got a different outcome. Okay, so he used similar wooden blocks, and he found that they sank to different depths depending upon the length of the column, depending upon the volume and the mass of the column. Okay, he assumed the density to be constant because he took only wooden blocks. Fine. Then, according to Airy, the crust was broken into different individual columns. To demonstrate his idea, he compared the situation with the wooden block. He compared the situation with the wooden block, and he finally concluded that uniform density with varying depth. He gave the idea, the dictum of uniform density with varying depth. Fine. The density of the columns is uniform, but the depth is varying. Fine. The density is uniform, but the depth is varying. So remember this thing about Airy: uniform density with varying depth. रट्टा मार लेना इस चीज को. Okay. Then what he said, that the isostatic equilibrium is achieved locally. For example, if there are mountains over here, then an isostatic equilibrium will be achieved at this place at a certain depth. If there are plateaus over here, there will be isostatic equilibrium achieved, okay, at a certain varying depth. Okay, at different depths, the isostatic equilibrium will be found. But there was some criticism. He gave this explanation. There were some criticism. The first criticism came from Pratt. Okay, since he assumed that all the land features are of same density, Pratt said that no, they are not of same density. Fine. As we today know, we have also seen the continental crust. It has a density of 2.7 gram per centimeter cube. Okay, it is different. It is lighter than that of the oceanic crust, almost 3 grams per centimeter cube. Fine. So Pratt gave the first criticism that the density is not uniform along the crust. Okay, what Airy assumed, that there is horizontal uniform density. A uniform density is observed horizontally. Fine. But today we know that there is no such horizontal uniform density. Then the second criticism that was given about Airy, he said that there are depths of varying length. Okay, and if we talk about the principle of flotation, when we talk about the principle of flotation, the principle of flotation says that if one part of any object is floating on a surface, is floating on a liquid surface, almost 9 parts will be inside. Okay, so if we are assuming that of varying length, okay, if we are assuming about the Himalayan mountains are almost 8,848 meters, okay, high. So just imagine the route that it might be having. Just multiply it by 9. For rough figure, we can say it is 9 kilometer. So almost 81 kilometer route will be there below the Himalayan mountains. At that time, there was no plate tectonic theory. Okay. So the other criticism came that if such huge is the length of the route of the Himalayan mountains, then the crustal part, if such huge is the depth, the root of the Himalayan mountains, at such depth, the crustal part will completely melt. Okay, the crustal part will completely melt. But recently, with the help of plate tectonic theory, we have observed that he was correct. Okay, but Pratt at that time he gave the criticism that if such a huge root is present, it will completely melt. So there is only one criticism of Airy, that is of uniform density. Fine. So any queries, any questions, any doubts up till here? Any queries, any questions, any doubts? Equal length. E- Equal length high nahi, because he used wooden blocks of different vertical length. You're talking about, अगर इक्वल लेंथ के लिए रहते सारे तो क्या होगा रहता? अच्छा, जितना ऊपर है उतना ही नीचे बोल रहे हो? हाँ हाँ, क्वेश्चन क्या है? हाँ हाँ, इक्वल डेंसिटी कैन, वही तो बोला. कहाँ ध्यान रहता है यार, एक ही तो क्रिटिसिज्म है एरी का. ओके, इक्वल डेंसिटी. Later plate tectonic theory has proven that okay, different lengths and such deep lengths are present. याद है वो डायग्राम? uh, about the interior of the earth, we are talking about the different layers. यहाँ पे Himalayan mountain ranges थे. I said the crustal part below the major mountain ranges is the deepest, but it is thinnest at the ocean floor. Okay, especially thinnest at along the mid-oceanic ridges. Fine. So you can just write 2-3 lines in short. Huh? वही तो कहा कि इट इज डिस्प्लेसिंग द मैग्मा प्रेजेंट ओवर हियर, और ये बहुत बाद में पता चला. ओके, इट इज डिस्प्लेसिंग द मैग्मा प्रेजेंट ओवर हियर. वो डायग्राम याद करो, वो डायग्राम याद करो. लेट मी शो यू दैट डायग्राम अगेन. That's what I said. He used certain terms. He used the term like lava. He used the crust. For crust also, he said Sial. Okay. And when he said Sial, he assumed that the entire crust was made up of only Sial. And that's why it had a complete uniform density. Okay. So these were the criticisms of Airy. Oops. You remember this diagram? दिख रहा है? यहाँ पे क्या हो रहा है? इट इज डिस्प्लेसिंग. यहाँ पे एस्ट्रोनोस्फियर कम है, फिर ठीक है, इट हैज बीन डिस्प्लेस्ड. फाइन. सो It was, it has been derived now through different indirect sources that yes, the roots below the mountains are actually quite that deep. तब ऐसे कुछ भी नहीं था. Okay, they were just giving hypothetical imaginary theories, okay, based on some different mathematical gravitational force calculations. Based upon that, they were giving different theories. Fine. Now we know that okay, these are the actual features happening inside the surface of the earth. Fine. So that's with the airy. You can just write, and these criticisms were given by Pratt himself. Okay, these criticisms were initially given by Pratt only. किसको? हाँ हाँ, हम बाद में बोलेंगे जब हम प्लेट टेक्टोनिक व्यू आएंगे. ओके, दैट टाइम हीज व्यू अबाउट द एक्सटेंशन ऑफ द रूट हैज बीन एक्सेप्टेड. ओके, हाँ, तो उसको डिस्कार्ड कर दिया, बस उसकी रूट थ्योरी को तो अप्लाई एक्सेप्ट कर लिया गया है अभी. ठीक है, सो यू कैन राइट फ्यू पॉइंट्स. It is probably given in your notes, but still I'll dictate in simple terms. According to Airy, the crust which he called as Sial was broken into individual columns of uniform density. Each of these columns achieves the isostatic balance. Each of these columns achieves the isostatic balance individually by replacing the same weight of lava material as their own weight which varies with the size of these columns. Matlab, when Airy gave his theory, he didn't even say that there might be such huge length of roots. These were later criticized by the others. Okay, so own weight which varies with the size of these columns. Okay, this diagram is there in your notes. Oh, ये निकाल लो. Right, next point. He suggested that elevated regions would be underlain by less dense material. Elevated regions would be underlain by less dense material such that there is substitution of heavy lava by the lighter crust. So basically, the magma, which he called as the lava, okay, it is getting displaced because of the though high weight of the crust, but lower as compared to the lava below. Okay. In other words, different sized crustal columns. In other words, different sized crustal columns occupy different depths in the substratum. Different sized crustal columns occupy different depths in the substratum. Then he conducted some floating experiment. Don't write that. Just simply write the summary of his idea was the summary of his idea was uniform density with varying depth. Uniform density with varying depth. That is, the density does not changes horizontally. Density does not changes horizontally, but vertically within the columns. But vertically within the columns. This was the reason why the Himalayas have lesser gravitational attraction. This was the reason why the Himalayas have lesser gravitational attraction, as the denser lava beneath is replaced by lighter roots of the Himalayas. Thus, isostasy is achieved locally. Thus, isostasy is achieved locally. Then write criticism in just two lines. Criticism. Pratt has criticized Airy for neglecting. Pratt has criticized Airy for neglecting the role played by the horizontal density of the crustal columns. Pratt has criticized Airy for neglecting the role played by the varying horizontal density of the crustal columns. Example, the oceanic crust is denser than the oceanic crust is denser than the continental crust. In fact, if we see the continental crust itself, okay, the continental crust itself, there are different densities present. Okay, so this is the criticism. This is the only criticism of Airy, but there is another you can write. Okay, it was given by Pratt. If Airy's view is accepted in totality, if Airy's view is accepted in totality, then the features like Mount Everest should have a route equivalent to 79,000 meter. Check in your notes, I think it is given as 7,900 meter. Change it. 79,000 meter. Such a long route is unsustainable as it melts at such greater depths due to prevailing high temperatures. Is unsustainable as it melts at such greater depths due to prevailing high temperatures. ठीक है? So in exam, if you get a question on Airy, okay, explain his theory or evaluate theory. If it is asked only the criticism part, usually criticism part won't be asked because there are hardly anything in that much detail. Okay, usually in examination you always get a comparison type of question, compare theories of Airy and Pratt. I'll discuss about Pratt now. Fine. So that's it with the Airy. I hope everything is clear. Okay. Now let's move on to Pratt. The Pratt's view is also called as the varying density with equal depth. Now, since Pratt has criticized Airy that the density is varying horizontally, okay, what he assumed that at a certain depth there is a layer. There is a layer. At that layer, all the objects that are present on the surface of the earth, they behave in a similar manner. Okay, at that layer the density of all the varying columns present on the surface of the earth becomes same. Okay, he called that layer as the level of compensation. Fine. At a certain depth, all the landforms present on the surface of the earth, they okay, they their density become uniform, and all the objects they tend to melt. Okay, so while drawing this diagram, थोड़ा सा नीचे कर लेना उसको. I'll give you some points, then you draw this diagram. Here is the level of compensation. Fine. So what he did is he studied the different rocks of the Himalayas, and he found that there was some variations in the density. There was some variations in the horizontal. There was variation in the density horizontally. Okay, if he collected rocks from Himalayas, he collected soil from the Indian plains and all. Okay, they all were settled in India only. Okay, during the British Raj. So they conducted experiments and he found that the density is different. Okay, and he assumed that at a certain depth there might be a level of compensation below which the all the varying landforms, they are behaving in a similar manner, they are having a similar density, and beyond which they will tend to melt. Okay, so you can just write in short. By studying the rocks of the Himalayas and neighboring plains, Pratt found that there is variation in the density. Pratt found that there is variation in density of different landforms present on the surface of the earth. He concluded that there is a line of compensation. He concluded that there is a line of compensation above which there is horizontal variation in density. There is a line of compensation above which there is a horizontal variation in density. The density, however, does not change within a single column. Thus, he gave the phrase varying density with equal depth. The density is varying, okay, and the depth is uniform. So just like Airy, he also assumed that there are individual blocks of different landforms. Okay, this you can also write as a criticism of him. Okay, just like Airy, Pratt also assumed that different land features are nothing but individual blocks floating over the line of compensation. You can write his criticisms. You can just imagine that is it possible to have such type of condition? Okay, is it possible if there is varying densities? Okay, if the density is varying, then how come there will be a uniform depth? It has to be changing, it has to change as per the change in the density of the different blocks present on that liquid medium, present above that liquid medium. Okay, so this was the criticism of Pratt. While giving his theory, he countered Airy that there is change in the horizontal density. He addressed that okay, there are columns of different densities, but he went on to say that they are floating at a certain depth. Okay, they are floating above a liquid medium up to a certain depth, beyond which their density becomes completely equal. Fine. So basically, he also gave the concept of flotation. He also gave the principle of flotation, but he violated the principle of flotation by saying that they are floating at a similar level. Okay, because we know about the flotation principle. If there is one portion extending above, there has to be some more portion below. Okay, so basically he said that while criticizing Airy, he said that if the Himalayas are almost 9 kilometers long, then its route has to be more than 80 kilometer. He is also talking somewhat like that about the flotation principle, but he is in fact violating that principle as well, okay, by considering a level of compensation. So you can just write his criticisms. Pratt successfully takes into account the horizontal variation in density. दूसरों को क्रिटिसाइज करने के चक्कर में खुद के थियोरी में ढेर सारी गलतियां कर दी उसने. The horizontal variation in density, but it is full of errors. Pratt criticized Airy for using law of flotation. But later pointed out by Bowie, another scientist came to criticize now. अभी प्रैट को क्रिटिसाइज करने के लिए और एक आ गया, ठीक है. बोवी क्या था? Pointed out by Bowie, the law of flotation is implicit in the concept of Pratt. The law of flotation is implicit in the concept of Pratt. As pointed out by Bowie, the law of flotation is implicit in the concept of Pratt. Basically वो भी law of flotation के बारे में ही बात कर रहा था, ठीक है. Pratt opines that different cyclic columns occupy same depth within the interior of the earth, which is in direct contradiction with the evidence given by seismic studies. Varying density with equal depth, ठीक है. एरी के बारे में जब लिखोगे तब यूनिफॉर्म डेंसिटी क्या था पता नहीं, in direct contradiction with the evidence given by seismic study. Seismic studies देखा है हमने, okay. Plate tectonic theories we have already seen. I just showed you the diagram, okay. There are different depths for different landforms. Any queries, any doubts up till here? Fine, ठीक है. So when we talk about airy, uniform density with varying depth, ठीक है. And when we talk about Pratt, with uniform depth, okay. You can draw this diagram, निकाल लिया होगा, ठीक है. Then there were other theories as well given by different geographers, okay. I'll talk about those theories. Those theories were basically nothing but they were simply evaluating what was the theory, what was the hypothesis given by Airy and Pratt. So in isostasy, basically these are the two important theories. In examination also, you will always and always get a question only from these two only, okay. Because other theories, other geographers, what they have done, they have simply used their idea, they have simply used their information to present their own view. One such geographer, geophysicist was Heiskanen. Okay, Heiskanen, what he simply said that what was the criticism of Airy? What was the one criticism of Airy? That he assumed that density is uniform horizontally. Okay, so Heiskanen said that no, there is no uniform density horizontally. Okay, it is changing. What was the criticism of Pratt? Uniform depth. So what he said, Heiskanen said that there is no uniform depth. So basically what he did, उसने कुछ किया नहीं, बस उनके जो criticism थे कि उनको बोल दिया कि नहीं ऐसा नहीं है. Okay, he would have used some data and all information, but basically his theory was only that much. So you can just write about it. Remember, in exam you'll always get question regarding compare the views of Airy and Pratt. Okay, so we'll be taking a question on it at the end. Hiskanen tried to achieve a balance between both the viewpoints, though his ideas are more in line with Airy's view. It's there, I think. It's there, fine. So I'll just dictate it so that you'll be able to recall it. According to him, isostatic adjustment is achieved by variation in the thickness of crustal blocks as suggested by Airy, as well as by the variation in the density between columns as suggested by Pratt. Okay. According to him, three-fourths of the compensation weight of crustal columns is achieved by root formation, and one-fourth is attained by difference in density. So what he said basically, 75% he accepted Airy's view, and one-fourth, the remaining 25%, he accepted Pratt's view. That there is horizontal change in density, and when it talks about the depthness, he accepted Airy's view. Fine. So three-fourths of the compensation weight of crustal columns is attained by root formation. Okay. So whatever the equilibrium that is being achieved, he said that the three-fourths of that equilibrium, 75% of the equilibrium is achieved because of the depth, and one-fourth, that is 25%, is achieved because of the change in density, horizontal change in density. Okay, so basically कुछ नहीं किया, बस बोला कि 75% theory of Airy is correct and 25% theory of Pratt is correct. Fine. अगर इसका भी कोई डायग्राम अगर निकालना है तो you can draw this one. Okay, the density varies in each section horizontally as well as the depth changes. Fine. So you can draw this diagram. Done. It is important to read the scientific journals. Okay, आप भी कुछ ऐसा क्रिटिसिज्म ढूंढ लो और अपनी थियरी दे दो. ठीक है, बस उनके क्रिटिसिज्म को बोल दो नहीं ऐसे नहीं होता, पता चले आपका भी बुक में नाम आ गया. Any queries, any doubts up till here? See, this is the most complex, isostasy is the most complex part of geomorphology. Okay, but if you have a good imaginary view, all your past basics and everything are clear, especially about the interior of the earth, this becomes a quite easy topic. हाँ, यहाँ पे density varies in each section. There is criticism of Airy, so he countered the criticism of Airy that the density varies in each section, and he उसने अपना खुद का डायग्राम बनाया और अपनी थ्योरी दे दी. ठीक है? So since the density is varying, each column will have different density. It will reach to a greater depth, and thus lead to displacement of the lava as said by Airy, displacement of the magma below accordingly. Fine. Then when it comes to isostasy, after these geophysicists, they gave their theory. The most modern theory that we have is the plate tectonic theory. Okay, plate tectonic theory, since it has been successful in explaining most of the landforms, land features occurring on the surface of the earth, plus different tectonic activities taking place. Similarly, this theory is also being utilized for explaining the concept of isostasy. Okay, the plate tectonic theory. Today, as we know, first of all, the crust, the lithosphere, okay, crust now today called, means when we are talking about the major solid slabs floating on the asthenosphere, which is a composition of crust and the uppermost part of the mantle, called as the lithosphere plates. Today, we know that the crust is not just composed of soil, but we have lithospheric plates which are floating over the asthenosphere. So, the plate tectonic theory, it rejects the traditional view. This was also used by Wegener. Okay, the soil is floating over the Sima. Okay, so plate tectonic theory, it rejects traditional view of crust, that is soil floating over the lava or the substratum. Instead, it says that it is the lithosphere, it is the lithospheric plates which are floating over the asthenosphere. Fine. So, the plate tectonic theory has basically this theory with different direct and indirect sources, especially the indirect sources. It has proved that it is the lithosphere which is floating or moving over the asthenosphere. Also, it rejects the claim given by Airy and Pratt. What Airy and Pratt said, that the different land features, they are made up of different individual columns. Okay, but today we know that lithospheric plate is a massive, solid, irregularly shaped slab of rock. I gave the definition about lithospheric plates during plate tectonic theory. Massive, solid slab of rock. Okay, they are not individual columns. Okay, so the plate tectonic theory rejects the second view given by Airy and Pratt, that is the different landforms present on the surface of the earth, they are not individual columns. Fine. Okay, any doubts, any queries up till here? दोनों, as I said, that Pratt criticized Airy because Airy, not knowingly, he used the concept of law of flotation, and Pratt said that if Airy is following the law of flotation, then there will be the root will be of great extent inside the interior of the earth. Pratt, he said, he criticized Airy for using law of flotation. Pratt, then he gave, while giving his theory, he said that, okay, I'm not using law of flotation. But if you look, Bowie said that if you look at the theory given by Pratt, he is also using law of flotation. Okay, though he is saying that I am not using, but he is, it is implicit in his theory that he is using law of flotation. Fine. Pratt is violating the law of flotation because Pratt, he didn't say, Airy didn't say that there is that root. It was derived from his theory. Okay, and it is true. Today, by plate tectonic theory, we know that the mountains, the Himalayas, have that great extent of root. Okay, so law of flotation used, not used, but which was there in the theory of Airy, it is correct. It is correct. But if you talk about Pratt, what he says, at a certain level, at a certain depth, all objects will be having equal density. ओके आगे जाके देखेंगे कि अगर एस्टेनोस्फियर में आप एक डेप्थ पे जाओगे एवरीथिंग विल बी मेल्टिंग. Okay, so at certain depth there will be a uniform density. Fine. So कहाँ थे? Yeah. So when we talk about the plate tectonic theory, the plate tectonic theory helps us in understanding about the crust, about the lithosphere. Okay, it helps us in rejecting the previous views of Airy and Pratt when it comes to the lithospheric part. Then also we understand that the lithosphere is not one. It is not broken into individual blocks, but it is a solid, massive slab of rock. Okay, as we all have studied the concept of plates acting as an efficient stress guide. याद है ठीक है then there are certain fractures present but they are not acting as an individual block of landforms. Then the next thing is in the process we find that there is actual presence of root formation. The plate tectonic theory has proved that there is actual formation of roots of that much deeper length. Fine. I'll dictate this. इसके फोटो कहाँ ले रहे हो ठीक है you can just write in 3 lines plate tectonic theory viewpoint. First, it rejects traditional view of crust or lava floating over crust or sile floating over the lava or substratum. Okay. Instead, it says lithosphere floating over asthenosphere. Over the lava or substratum. Instead, it says lithosphere floating over asthenosphere. It rejects the claims of both Airy and Pratt that crust is broken into small individual columns. It rejects the claims of both Airy and Pratt that crust is broken into small individual columns. We have seen that in the plate tectonic theory, there is continuous recycling of the oceanic crust. Okay, there are formation of different landforms taking place on the surface of the earth, fold mountains, rift valleys, and all. So there is continuous loading and unloading taking place on the different landforms on the surface of the earth. Okay, loading and unloading. Suppose there's erosion taking place, there is erosion of the mountains taking place, erosion of the mountain taking place. As a result, the height, the width of the mountain goes on decreasing. Fine. So there is unloading taking place on different land features, but there is a deep root present. The weight over here has now decreased to a great extent. So there, over a long period of time, there might be uplifting over here. I mean to say that this root this route, which was somewhere around 80 kilometer, it will might push little bit upward. ठीक है, इसके ऊपर का वेट अगर मैं कम कर दूं, तो ये थोड़ा सा ऊपर उठ जाएगा, but it will happen over a very long period of time. Glacial ice, I'll come to all these things. ठीक है, fine. So you can write in the process they do lead to root formation. Plate tectonic theory, in the process they do lead to root formation. However, it can be stressed that the most important thing about plate tectonic theory is when Airy and Pratt gave their theory. When Airy and Pratt gave their theory, what they said that all the landforms, they behave like individual columns. As a result, their roots will also be some individual columns itself. Okay, but in the plate tectonic theory, we have seen that the roots, they are not individual column present somewhere locally. Okay, they are not locally present. मतलब अगर ऊपर माउंटेन है तो उसका रूट लोकली वहां पे ज्यादा डेप्थ पे एक लोकल पोजीशन पे ही नहीं रहेगा, बट द रूट्स आर स्प्रेड रीजनली. The roots are spread over long distances. They occupy large regions. So they are spread regionally, but not locally. Okay. So the third thing which was explained by plate tectonic theory was the root. You can just write. However, it can be stressed that after that, you can write the root is regionally spread. The root is regionally spread and its nature is different from the local root suggested by Airy. Okay, you can draw this diagram if you want for this explanation. See, initially, suppose there is one landform present on the crust, okay, and there is an asthenosphere, there is loading. What Airy said that a local root will be formed, okay, due to fracture faulting, a local root formation will take place, and thus at a certain depth it will achieve an isostatic equilibrium. At a certain depth, it will achieve an isostatic equilibrium inside the asthenosphere. But when we talk about plate tectonics, we know that it is a solid slab of rock extending over a great length. Okay, and if there is some loading taking place, if there is a mountain over here, that entire lithospheric slab, it will tend to bend, okay, and thus it will move in different directions, as we have already seen. Then there won't be local roots, but there will be regional root formation. ठीक है? कुछ doubt? अच्छा, अभी क्लियर हुआ? हो गया? यही क्रिटिसिज्म था एरी का और एक, ठीक है, फर्स्ट डेंसिटी, हॉरिजॉन्टल डेंसिटी, सेकंड लोकल रूट फॉर्मेशन, ठीक है. नाउ अभी तो पता चला प्लेट टेक्टोनिक थियरी इज अ क्वाइट रीसेंट वन, हार्डली 50-60 years, okay. Criticize नहीं कर रहा है. The thing is that as we studied in plate tectonic theory, we studied the different sources that has provided us this information. So now we have n number of scientific data available with us that is helping us in explaining these different features, these different phenomenons. Okay, ये लोग what Airy and Pratt, at that time there was no such computerized instruments and everything. So whatever theories that they were giving on the basis of whatever limited information they had at that time. Okay, but now plate tectonic theory is a combination of n number of theories. We have already seen those theories, continental drift theory वगैरह, convection current theory, Arthur Holmes, फिर उसके बाद ocean mapping वगैरह, floor and all. We have seen all those theories. Based on all this information, we can say we have this scientific data now available with us that is helping us understanding the interior of the earth. Okay, initially कुछ नहीं था. ओके, आपका माइंडसेट भी ऐसे ही रखो. ओके, बी ओपन, कुछ नहीं था पहले. अभी अभी तो धीरे धीरे ये सब पता चल रहा है. ठीक है, एज आई सेड यस्टरडे ऑल्सो, आपको ही बोला शायद मैं कि रिसेंट अल्लाह बन फॉल्ट, ठीक है, जब पता चला तब फिर इंट्राप्लेट क्वेश्चन था शायद आपका. ठीक है, वही. देन वी स्टार्टेड प्लेट टेक्टोनिक थ्योरी, देन अगेन गिव एन एक्सप्लेनेशन व्हाई देयर इज अ फॉल्ट एट दैट पर्टिकुलर लोकेशन. So basically, plate tectonic theory is helping us understand the concepts, and in future we might apply these. Now we know that there is a fault line seismic gap below the Himalayas. Okay, so we can now predict to some extent कि okay, this region is a high intensity earthquake zone. We have already seen the map of India, the intensity zone map of India. We were able to draw that map based on the different our observations based on the plate tectonics. Okay, so accordingly we can take precautions now. We know which places on the surface of the earth have different boundaries, convergent, divergent, okay, transform. Regional root formation accommodates the weight along with the flexural, FLEXRUL, flexural, check the spelling, XURAL, flexural strength of the lithosphere. Thus isostasy is achieved regionally rather than locally. Any doubts, any queries up till here? See, now huge loading, huge weight is there. What will it happen? Slowly and steadily, there will be fracturing and faulting as per his views. Okay. At a certain period of time, when the load becomes too much heavy on the crust, okay, at a certain period of time, because of the heavy load, heavy weight, the crust will tend to fracture. Okay, if I'm putting a heavy pressure on this for a prolonged period of time, at certain period of time it will lose its strength, it will lose its tensile strength, and as a result there will be cracking and fracturing over a prolonged period of time. यहाँ पे for example I'll draw. Suppose this is the crust, fine. Initially, there is a loading on this, okay. He said the soil is floating over the cyma, so this is quite weaker section. Slowly and steadily, what will happen? It will move in the downward direction. यहाँ पे fracture होना start हो जाएगा, ठीक है? And to achieve that equilibrium stage, it will tend to move downward, ठीक है? It will tend to move downward. If you construct a building, ठीक है, without a foundation, what will happen? It will fall in some or the other direction. To achieve the equilibrium, what will happen? It will tend to move little bit downward. Suppose if you are standing on a, what I say, clay soil, okay, you won't be able to balance yourself properly. What we will do? You'll push your feet a little bit deeper, okay, to balance yourself. Some similar like that, the landforms present according to his views, when initially there was considered that they are simply floating on some liquid material, what will happen? It will sink to a certain depth to achieve a stability. Fine? Clear? कहाँ थे? But plate tectonic theory has proved that what will happen is, if there is a land feature present on the surface of the earth, okay, the lithospheric slab, it acts like a flexural strength. It will flex, okay, okay, it will move in different directions, and thus it achieve the isostatic equilibrium. Yeah, some point it has to break, okay, at some point it has to break. There will be different forces acting on it. There will be slab pull mechanism, ridge push mechanisms taking place. I've already discussed in the plate tectonics, okay, at certain point, and thus the regional roots will be formed, okay, over and spread over an entire region and not at a single place. Regional roots, okay. If you consider the mountain length, just consider the Himalayas, they are so huge, okay. Their width, if you're talking about 500, 600 kilometer, okay, it's huge. So a regional route will be formed, not just locally, like a, suppose this is the mountain, not just a simple initially they assumed that such type of route will be formed, okay, but now it is known that it is extends over an entire region, okay, spread over long distance. I'm just showing it as a representative. You can extend it like this, okay. A regional very long width route will be formed. Fine. Then next is the isostatic adjustment. Just now, as you said about the erosion, okay, glacial erosion, the isostatic adjustments can occur because of two reasons. One is the anthropogenic and the other is the natural. When we talk about the natural reasons responsible for isostatic adjustments, just now, as you pointed out, the erosion of the mountains, okay, the erosion of the mountain takes place over a prolonged period of time, and as a result, what happens is there will be some changes observed. There will be some changes observed in the interior of the earth, especially with respect to the root. when we talked about the convergent plate boundaries, what is happening is, let's say two plates are colliding with each other. The one plate is subducting. After a certain period of time, what will happen that these plates will merge to a great extent, not exactly, but they will merge to a great extent. Their particles will become compact, and as a result, when they are moving, there might be such type of bend observed at particular place. Similar such bend has been found along the foothills of the major mountain ranges, especially the Indo-Gangetic plain. Okay, they are right along the foothills of the Himalayan mountain chain. Initially, there was a bend. Suppose these are the mountains, Himalayan mountains. Immediately next to it, initially there was a bend. This bend was later filled up by the depositional of sediments brought down by the rivers. Fine. There was deposition taking place in this region. But if you talk, initially there was a huge bend observed. Similarly, what will happen is this image clear? Yeah, ये काफी blur है. Fine. Initially, there is deposition, and due to initially there is a bend. Okay. As a result of the bend, the depth of the root, the magma below it will be displaced accordingly. Fine. As the erosion continues, the sediments are transported towards the subducted portion along the foothills of the mountains, and over a period of time, there will be isostatic upliftment of the mountains. Okay. Initially, it is said during the Pleistocene glacial period, there were huge glaciers present on the surface of the earth. Plus, there were huge glaciers all on the Himalayan mountains. Okay, slowly and steadily, due to warming, those glaciers melted. Most of those glaciers melted, and still the Himalayas are now rising. It is also considered as one of the reason for the isostatic upliftment of the Himalayas. Fine. As the glacial load, just now as you're talking, as the glacial load over the Himalayas have over a period of time, the glaciers have retarded. Okay. They have decreased. As a result, the weight over the Himalayas has decreased, and they are in an isostatic disbalance. Okay. Because of the isostatic upliftment. I hope this is I hope this is clear to all of you. Fine. Now, as the deposition is taking place in the bend along the floors of the mountain, what will happen? There will be little bit of subduction observed. Fine. You can just imagine how uh, deep the Indian Indo-Gangetic plains are. Okay, they are quite deep. Their length is quite huge because of the heavy depositions over a prolonged period of time. They have been filled up with the sediments, with the different layers of the soil, and as a result, now at that place, somewhat more subduction beneath because of the heavy weight of the sediments. A subduction is observed, and accordingly, the mantle below, it will change its positions, it will change its location. Fine. Hmm. In it is called as the collision type of convergence. Okay. In collision, see, the Himalayan plate, continental plate, the Eurasian plate, continental plate, both almost of the same density. In that case, what is happening? The the Indian plate, little bit less dense. It is subducting to a great extent, but it is not, hmm? Sorry, more dense. Ulta hai. Sorry, Indian plate more dense. It is subducting below the Eurasian plate. Okay, it is subducting below, but the rate of subduction is little bit less, and it is extending to a great extent inside the what you say interior of the Earth. It is colliding, you can say. It is subducting also. It is moving below the, अगर moving below ही हो रहा है तो उसको हम उसी के नीचे सबडक्ट हो रहा है ऐसे बोलेंगे. ओके, बट इफ यू आर टॉकिंग अबाउट सम अदर प्लेट, अगर पैसिफिक प्लेट की बात कर रहे हो तो वो एस्ट्रोनोस्फीयर में जाके सबडक्ट हो रही है. Okay, but the Indian plate and the Eurasian plate, they are colliding, and the Indian plate is just simply subducting below the Eurasian plate, or it is simply moving below the Eurasian plate. ठीक है. As a result, the root of the crust below the Himalayan mountains is quite large. Okay, I hope it is clear. You can ask your question once again. मैं ही भूल गया क्या क्वेश्चन था. हाँ, folding of the mountain I'll be covering in the next lecture. Okay, basically अभी understand करने के लिए बस ऐसा करो कि two plates are colliding. ठीक है. पहले क्या था? पहले there was a sea. Okay, Tethys Sea, because of which accretionary wedges were formed. Okay, because of fluvial deposits, accretionary wedges were formed, and now those plates are still colliding. They are still colliding with great force. Okay, since they are colliding, what will happen? यहाँ पे तो fold ही हो गए ना वो. अगर मैं इसको हिट कर रहा हूँ बार बार तो एक के ऊपर एक मूव होना स्टार्ट हो जाएगा वो. ठीक है. यहाँ पे बेंड हो रहा है, कहीं बेंड हो जाएगा, फिर ये पोर्शन अपलिफ्ट हो जाएगा. ओके, प्रेशर इज क्वाइट ह्यूज. इट इज मूविंग, बेंड होगा, फोल्ड होगा. ठीक है. इट विल कंटिन्यू ऐसे. एट सम प्लेस इट विल बेंड, सम प्लेस इट विल बी इरप्टेड इन द फॉर्म ऑफ फोल्ड. ठीक है. एनिमेटेड में दिखा दूंगा इन माउंटेन बिल्डिंग थियरीज. ठीक है. आई हैव दोज एनिमेशंस विद मी, so I'll show it at that time. So isostatic adjustments can occur due to two reasons. One is the natural adjustment because of the erosion of the mountains. Okay. The second is the melting of the glaciers. As I said, during Pleistocene period, there were huge glaciers present on the surface of the earth. Okay. So what happens is, since huge mass of glaciers are present, what will happen? The crustal part, it will lead to subsidence due to the heavy weight of the glaciers. Fine. As it is subsiding, what it will do is it will displace the molten magma below it to a certain extent. A huge glacial deposit has taken place. Now the weight is increasing over it. As a result, this magma will get displaced. Fine. Because of the crustal load present over it. Fine. Because of the weight of the ice. Similarly, if that weight is removed due to deglaciation because of the erosion, as the Pleistocene period ended, then the glaciers began to melt. Similarly, removing the weight will lead to upliftment, and again the lower positions will be occupied and the depth of the thickness of the crust will change, and thus it will tend to maintain its state of equilibrium, its state of mechanical equilibrium. Fine. So basically, the different landforms or the land features on the surface of the earth, they are trying to maintain their mechanical equilibrium floating over the liquid asthenosphere. Fine. This is nothing but isostasy. Any doubts, any queries up till here? You want to draw these diagrams? ये नहीं है नोट्स में? क्या बात कर रहे हो? निकाल लो फिर, निकाल लो फिर, ये निकाल लो ग्लेशियर्स. ठीक है, सिंपल डायग्राम्स निकालो, डोंट ऐसे ऐसे सिंपल डायग्राम्स निकालो. ठीक है, और एग्जाम में भी ऐसे ही सिंपल डायग्राम निकालना. दैट विल सेव योर टाइम. नो नीड टू लेबल सारी चीजें, जस्ट ये दो तीन चीजें लिखो: ग्लेशिएशन, सबसिडेंस एंड मूवमेंट ऑफ मैग्मा. ठीक है, वेट ऑफ आइस, सबसिडेंस ड्यू टू वेट ऑफ आइस. अच्छा, बस नहीं, वही तो कहा, एक आइडियल कंडीशन है. आइसोस्टैटिक इक्विलिब्रियम डेफिनेशन में मैंने क्या था, इट इज एन आइडियल स्टेट which every land features present on the surface of the earth is trying to what you say, trying to achieve in the absence of any disturbing forces. In the absence, I think आप लेट आए थे. इन द एब्सेंस ऑफ एनी डिस्टर्बिंग फोर्सेस, हम ऐसी आइडियल कंडीशन को इमेजिन कर रहे हैं कि ठीक है, ग्लेशियर हो रहा है एंड देर आर नो अदर एक्टिविटीज टेकिंग प्लेस. अब सिर्फ ग्लेशियर हो रहा है तो सिर्फ ग्लेशियर्स आर ओनली पुटिंग वेट एंड वेट एंड वेट. ओके, बट वी आर कंसिडरिंग ऑल अदर फैक्टर्स दैट माइट बी प्रेजेंट साइमल्टेनियसली. इरोड भी हो रहे होंगे, okay, but we are considering all those factors as constant. Hmm. एक और है वही, थोड़ा सा रख दिया है साइड में. हो रहा था. जब, that's why it is said the Himalayan region has still not achieved its isostatic equilibrium. There will be some day in the future कि the upliftment of the Himalaya is going to stop. It has to stop. Okay, all these theories are have helped us understand all these features. Okay, and in future what will happen, they are presenting us with a view. They have provided us with an opportunity to understand what will happen in future. Plate tectonic theory, we know the different plates are moving in which direction, in different directions. We now know the major plates exactly in which directions they are moving. इन फ्यूचर व्हाट विल बी द कंडीशन ऑफ द कॉन्टिनेंट्स, ये भी हम अभी प्रेडिक्ट कर सकते हैं. एक नेशनल जोग्राफिक चैनल पे एक डॉक्यूमेंट्री भी है. ओके, अर्थ इन 3000. ओके, अभी 2022 चल रहा है, तो अर्थ इन 3000 4000 ऐसी एक मस्त डॉक्यूमेंट्री भी है, वो देख लेना. ठीक है, even the different animals on the surface of the earth, they will evolve in different ways. They have very well explained how the shape of the continent will be. Okay, now we all know that there is a divergent boundary along mid Atlantic ridge. They are diverting, the American plate is moving, फिर से वो एक साथ आने ही है. Okay, after a certain, अच्छा, after a certain period of time all the planets will again come back together. Okay, as I said, there were n number of supercontinents in the past. There was रोडेनिया, फिर उसके बाद पैंजिया आया, फिर अभी फिर से सारे अलग हुए. Then in future again they'll come together. हो गया. That's it with the isostasy. If you have any doubts, any queries, Alok, Alok, stop. See, this is the, as I said at the start of the lecture, this is the most means confusing and complex thing in the geomorphology. And I hope I was able to explain you in a better way. And trust me, I've explained this